concept of current, voltage and power in the electrical circuits, and we'll see that how they are related with each other. So let's start with the current. So what is current? So in simple terms, it can be defined as a flow of electrical charge. So to understand the current, first of all let's see the concept of electrical charge. So if you see any atom, which is the fundamental building block for any material, it consists of three primary elements. It contains proton and neutron, which resides in the nucleus, and the electron, which moves around this nucleus in the orbits. Now the electrons which are moving in the outermost orbit can be easily knocked out of the atom by just applying some little bit of energy, and these electrons which are in the outermost orbit contributes in the flow of current. So this electron possesses a negative charge, while the proton possesses a positive charge. Neutrons have a no charge, or electrically they are neutral. So when the same polarity charges have a tendency to move away from each other, while the opposite polarity charges have a tendency to move towards each other. So unit of the charge is a coulomb, and it is denoted by a symbol capital Q or either small q. When we talk about the charge of electron, sometimes it is denoted by a symbol small e. So the one electron has a charge of 1.6 into 10 to the power minus 19 coulomb. So to have a 1 coulomb of charge, we requires 4.28 into 10 to the power 18 electrons. That is the inverse of this quantity. So to have a 1 coulomb of charge, we require the charge of this much amount of electrons. So as we have understood the concept of charge, now let's talk about the concept of current. So let's assume that we have a one piece of copper wire, and electrons are flowing through this copper wire, and we want to find out that how many electrons are flowing through this copper wire. So let's take one reference point in this copper wire A at A dash, that is a cross section of this copper wire, and let's assume that the amount of charge that is flowing through this copper wire is a 1 coulomb. So if 1 coulomb of charge is passing through this reference point in 1 second, then we can say that the current which is flowing through this copper wire is 1 coulomb per second, or 1 ampere. So the current can be defined as a rate at which this electrical charge is passing through this reference point. The current is defined by a unit of ampere, and it is denoted by a symbol I. So to understand the concept of current, let's take a example of a tap water. The amount of water which is flowing through the tap depends on the rate at which the water particles are coming out of this tap. The higher the rate at which the particles are coming out of the tap, the more will be the water flow. Likewise, the higher the rate at which this electrical charge or electrons passing through this reference point, the higher will be the flow of current. So if 5 coulomb of charge is passing through this reference point in 1 second, then we can say that the flow of current is a 5 ampere. So to have a movement of this charge, we require some sort of energy. So these electrons or electrical charge will not contribute in the flow of current unless and until we apply some form of energy or external force. At room temperature, these electrons move randomly in all the directions, but because of that, the net motion of flow will be the zero. So to get a net motion of flow, we need to require to apply some form of energy. So let's apply this energy in the form of external battery, which is connected to this copper wire. So because of this battery, the electrons will be supplied to the one end of the copper wire. So the electrons, which are free electrons in this copper wire, will get repelled with this negative charge supplied by this battery, and these free electrons will move to the other end of the copper wire, and at other end of the copper wire they will get attracted to the positive terminal of the battery. So in this way we get a flow of electron from negative to the positive direction. So the electrons in the circuit flows from negative to the positive terminal. But in the electrical circuits, if you see, we generally take a flow of current from positive to the negative direction. So that is the conventional flow of current. So the conventional current flow is from the positive to the negative terminal in the circuit. So as we have discussed that to get a movement of this charge, we required some sort of energy, and that energy is measured in the unit of joule. So let's assume that we have a 1 coulomb of charge, and to move this charge from negative to the positive terminal, we require a energy that is a 1 joule. So if 1 joule of energy is required to move a 1 coulomb of charge from negative to the positive terminal, then we can say that the potential difference between the positive and negative terminal is a 1 volt. So that is a definition of the voltage. So voltage can be defined as the energy required or work done to move a unit charge from one point to the another. So let's say we have 2 points A and B, and at point A we have a 2 coulomb of charge. So to move a 2 coulomb of charge from one point A to the B, let's say we require 2 joules of energy. So the voltage or potential difference between this point A and B can be defined as a 2 joules divided by 2 coulomb, that is a 1 volt. The unit of this potential difference or voltage is a volt, and it is denoted by a symbol V. So the higher the amount of energy required to move a charge from one point to the another point, the higher will the potential difference. So let's say if 5 coulomb of charge is at point A, and to move this charge from point A to the point B, let's say we require 50 joules of energy. So the potential difference between the 2 points will be the 50 joule divided by the 5 coulomb, that is equal to the 10 volt. So to understand this concept, let's take one example. Let's say we have one ball at the ground and its weight is 100 gram. Now we want to throw this ball from the ground to the top of the one building which is having a height of 10 meter. So for this task we require some energy. Let's say for this task we require energy E1. Now in the another case we have a ball with the same weight or a mass, that is 100 gram. We want to throw this ball to the top of one building which is having height of 20 meter. So for that, let's say we require energy E2. Now here the energy E2 will be definitely greater than the E1 because the height in the second case is more. So the amount of energy required in the second case will be the more. So we can compare this example with the voltage. The higher the difference between the 2 points or higher the height of the building, the more amount of energy is required to throw a ball. Likewise, the higher the potential difference between the 2 points, the more amount of energy is required to move a charge from one point to the another point. Let's see the concept of power in the electrical circuits. So the power can be defined as a rate at which energy is supplied or consumed in the system. So this power is denoted by a symbol P, and mathematically it can be written as a E divided by T. That is the rate at which energy is supplied or consumed in the system. So it is defined by a symbol joule per second or a watt. While in the earlier case, the voltage mathematically can be written as a V is equal to E divided by Q. That is the energy required to move a unit charge. And the current I can be defined as a rate at which electrical charge is moving from the one reference point, that is a Q divided by the T. Now, as we were talking about the power, E is equal to E by T. So let's understand the concept of power by taking a one simple example. Let's say we have a 1 coulomb of charge at point A. We want to move this charge from point A to the point B. And the energy required for this task is, let's say, a 5 joule. And the time required for this task is, let's say, 5 seconds. So by the definition of the power, P, that is defined by a rate at which energy is consumed, that is E by T. Now here in this case, to move a 1 coulomb of charge, we required a 5 joule of energy, that is 5 joule of energy per 1 coulomb, and the time required to move this 1 coulomb of charge is 5 seconds, that is a 5 seconds per 1 coulomb of charge. So the power required for this task is 5 joule per 5 seconds, that is a 1 watt. Now let's generalize this term. Let's say we required E joules of energy to move a Q amount of charge, and the time required for this task is T, that is T seconds for a Q coulomb of charge, that is a power. So we can rewrite the terms like E by Q into Q by T. So E by Q is nothing but a voltage. As we have seen, the voltage can be defined as a energy required to move a unit charge, and I, that is a current, can be defined as a rate at which the charge is moving, that is a Q by T. So we can write power as a product of V into I. So power can be defined as a product of V into I. This is the very useful relationship between the voltage, power and the current. Now in electrical circuits, the power is either consumed or it is being supplied. So in electrical circuits, if you see, any element is either dissipating a power or it may be supplying a power. So how to know that element is supplying a power or dissipating a power? This can be found out by a simple sign convention. So we will take this sign convention, or we will use this sign convention to know whether this element is supplying energy or it is dissipating energy. So let's say we have one element and the voltage between the two terminal is a V. So if current is flowing out of the positive terminal from that element, then we can say that that element is supplying a power. Or if current is flowing into the positive terminal of that element, then we can say that that element is dissipating a power. So let's take one example to understand it very clearly. Let's say we have two voltage sources which are connected through one resistor. We have one voltage source of 5 volt and another voltage source of 3 volt which are connected by one resistor R. So the current will flow from higher potential to the lower potential, like the water flows from higher elevation to the lower elevation. So we will have a current in the clockwise direction, and because of the flow of current there will be a potential drop across this resistor R. Let's say that is a VR. So now let's apply sign convention in this across the all elements. So across a 5 volt source, the current is flowing out of the positive terminal. That means this element or this source is supplying a power. Now let's see a resistor. So the current is entering into the positive terminal of the resistor. So the power is dissipated across this resistor. Now let's see across a 3 volt voltage source. So across 3 volt the current is entering into the positive terminal. So this 3 volt is also dissipating a energy or a power. So the 5 volt is supplying energy and the resistor and the 3 volt voltage source is dissipating a energy or a power. So by using the sign convention method in any network, we can find that which elements are supplying a power and which elements are dissipating a power. So now let's just summarize that what we have seen in this video. So now let's just summarize that what we have seen in this lecture. We had seen the current, voltage and power in the electrical circuits and how they are related with each other. They are related with each other by this P is equal to V into I relationship. So I hope you are able to understand what is current, voltage and power in the electrical circuits. If you have any queries or doubt, please write in the comment section below.